Hello children, welcome to Yamuna's physics classes. Today we have to discuss the topic refraction at a spherical surface, that is section 9.5 of ray optics. In earlier videos we have discussed what is refraction, sign convention, the assumptions used here, the terminology, all these things we have discussed there. And actually we have to recap all these things when we do this topic. So if you have any doubts while going through or following me, please do pause, go back, watch the previous videos and then come back. Okay, hope you will do that. So let us start. Here we have two medias. Number one, it is air and the object is placed in air. Air is the rarer medium compared to glass, which is a second medium, N2. So ray of light is coming from rarer medium to the denser medium. And this is based on the main three assumptions. We are using many assumptions are there, but here we are coming across three major assumptions. Number one, the object is point, means the size of the object is much small compared to the distances you have taken, u, v, r, etc. And also the aperture in the sense that particular region where the incident light is falling, that is known as aperture. For a lens or a mirror, we take the diameter of the lens and mirror as aperture. So the aperture is very small, means you are taking such a big sphere and a small portion of such a big sphere you are choosing so that this remains linear, nearly linear, like plane itself. But here I have shown curved because the figure is a little bit small. Also, it's a magnified version. Clear? And one more thing, all the angles you have here, I, R, the other angles I have mentioned, alpha, gamma, beta, etc. All these angles are small angles. So the approximation of small angles is a must when you discuss ray optics. Clear? So first of all, let me recap the assumptions. What are the assumptions? Small aperture and small angle approximation, which means when theta is small, you have done too many times this approximation right from class 11 itself, where we are discussing the oscillation of a simple pendulum. It is restricted to pi root upon L by G is applicable for small oscillations alone. So sin theta is small, you give it as theta. Tan theta is small, it is theta. Why? Because theta gives 0, sin 0 is 0. Tan theta, tan 0. What is tan 0? Sin 0 by cos 0, that is 1. Therefore, cos 0 is 1, sin 0 is 0, upon 1 is 0. So, when theta is small, sin theta is theta, tan theta is theta. Moreover, you can replace sin theta as tan theta. Or instead of theta, you can replace sin theta or tan theta. No problem. So, that is what we are using here. Clear? So, applying the whatever all these things we have done just on the single tool, Snell's law. In this figure, you know, refraction is taking place only at one point. Actually, you have two incident rays, but refraction takes place only at one point. Why? This is the point where the refraction takes place. This is one ray, ON, NI. One ray. The other one is OP, PI. But that, as usual, it's a line which is along the principal axis. The ray is passing through the principal axis, means no deviation. Normal incidence, normal refraction. It's very clear, like a plane mirror itself. Clear? Okay, so it's go in the same manner. Angle I equal to angle R. So these two, this white and this orange, meets at the point I. Two rays are enough for image formation. So you get an image at the point I. So applying Snell's law to the point N. So applying Snell's law at N, what will happen? N1 sin I equal to N2 sin R. Written N1 sin I equal to N2 sin R. Approximation. Instead of sin I write angle I. Instead of sin theta, you can write theta. So sin I is angle I. Sin R is equal to angle R. Okay. Now, again you have this information. Exterior angle is the sum of opposite interior angles. Now suppose you have a triangle like this. If this is a triangle, these two are interior angles and the third angle is this. Opposite to that third angle, you call it as exterior angle. So we will say exterior angle is the sum of opposite interior angles. Likewise, from the figure it is clear, NOC, whichever name you can see, NCO, anything you can write. So you have angle I equal to angle alpha plus angle gamma. Angle I is equal to angle alpha plus angle gamma. Also, another triangle CNI. CNI. The stripes I have given. There you can see gamma is nothing but the sum of R and beta. To avoid confusion, I have written R in this manner, gamma in this manner. So gamma is equal to R plus beta. So these two informations we get the geometry of the figure. Now take the values of I and R, substitute in equation 1. What is I? Alpha plus gamma. What is R? Gamma minus beta. Substitute here, expand N1. Instead of all these values, all the angles, I substitute tan. Why? You can put theta same as tan theta. So instead of theta, I write everywhere tan. N1 tan alpha, N1 tan gamma, N2 tan gamma, N2 tan beta. Expanded and give the value of tan. And from the figure, you always memorize three angles, alpha, beta, gamma. We will be using the same denotation for the forthcoming sessions also. So alpha for object, beta for image, gamma for center of curvature. So substitute the values. In every case, you can see the opposite side is the same. I have drawn a normal from the point N to the point M, which is on the principal axis. So right angle triangle, opposite, every angles have the opposite sides as NM. So wherever you have write NM, 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 NM. But adjacent side will be different. Opposite side is the same, adjacent side will be different. For O, adjacent side is MO. For I, it is MI. And for C, it is MC. So for alpha, it is MO. For gamma, it is MC. And for beta, it is MI. But again, the approximation comes. You have a point object. Means what? The rays are coming parallel and close to principal axis. If it is coming in that manner, N will be a point somewhere very close to P. So what about M? M will be very near to P. So we will say P and M are close to each other just because you consider a point object. And paraxial rays, rays which are parallel and close to the principal axis. So P instead of M, I can write P itself. So instead of M, here M, 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 all the case I have written P, 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 P. Now you know the sign convention. All the measurements are done from P, the pole. And what's the condition? Whatever be the direction of incident ray, that is taken as positive, the reverse is negative. So left to right is the incident direction, that is positive, the reverse is taken as negative. Here you can see from the figure, R is positive, measured in this direction. V is positive, measured in this direction. What about U? U is measured in the reverse direction, so it becomes negative. Apply the values, N1 by PO, N1 by PC, N2 by PC, N2 by PI. So give the values. PO, definitely pole and object, minus U. Pole and center of curvature, plus R. Pole and center of curvature, plus R. Pole and I, plus V. Clear? Rearranging, finally you have the answer. Rearranging, taking R to the same side. N1R taken right side, that becomes minus n1 by r. Then n2v taken to the left, it becomes plus n2 by v minus the same minus n1 by u. So just look at the equation once again. We need to recollect this, just the equation itself, when we go to lens makers the next session. So for that, n2 minus n1, that is same as n2 minus n1. So n2 by v minus n1 by u equal to n2 minus n1 by r. Here what is r? The radius of curvature of this sphere of which the surface is a part. So that is r. So this is the relation. Once again, n2 by v minus n1 by u equal to n2 minus n1 by r. And this relation between u, v and r is good for any curved surface, whether convex, concave, real image, virtual image, no matter, light goes from where, reaches at where. So this is applicable to all the cases, real and virtual image formation. So you have to take down, learn, write and study. So this is a sure essay part question. So you have to write and study. So I pause. I'll just go back. You can take a screenshot. Just pause the video. Take a screenshot. Write and study. So thank you for listening. Thank you.